Okay, so we're going to talk about some of the properties of exponents. And as you go through this video, I almost want to encourage you to not think about it as notes, but as an exercise or practice. So we'll talk about the properties. Definitely write these down if you haven't already. And especially if you don't know them, write them again. Repetition is a good way to remember things. But then going forward, pause the video, try the problem, and then push play and work the problem out with the video as you need to, or just check your answer with the video. But use that pause and play button a lot on this video. You learn math by doing math. So make sure you're doing the math and you'll be good to go. Okay, so real quickly through the rules of exponents. First, notice that all of these apply only if the base is the same on each of them. So if the base is different, it doesn't apply. You can't do anything. So just keep that in mind as you work. But if you are multiplying like bases, then we're just going to, instead of an example, we'll just do like a summary. We're going to add exponents when you multiply. If you multiply, up high multiply. So if you raise a power to a power, then you multiply exponent. The power of a product. So this is just showing you that if you can kind of think of it like distributing, you can take the exponent and raise each term or each base to that same power. This is the tough one, or one of the tough ones. If you have a negative exponent, it moves it to the other side of the fraction. And so it could mean that like x to the negative 2 power is 1 over x squared, and the base goes with it. Or you could also go like if you had like 1 over 2x to the negative 5th, then this would be 1 over 2. I'm running out of room, so I'm going to squeeze it in. And then x to the 5th would be on top. So only the base goes with it, not the extra stuff. So the 2 has its own exponent to the first power. It doesn't move anywhere. Anything to the 0 power is 1. If you are dividing like bases, then you subtract exponents. Oops. And then power of a quotient. So if you're raising a fraction to a power, you raise the top and bottom to a power. Okay, so once again, as these problems come up, or if you're working them out, push pause, try them, and then let's see how we can do these together. So this first one, we have b to the negative 4th times b to the 6th times b to the 7th. You just add exponents, just add straight across. So negative 4 plus 6 is 2, and then plus 7. This would be, I'll just write it out. It'd be b to the 9th. Here, there's a couple different ways to do this one. I'm going to go ahead and multiply the exponents first. So that gives me r to the 6th over s to the negative 9. And be really careful with your signs. It's going to be common error. And then do not flip the fraction, but keep the r to the 6th on top. That's positive. But the s to the 9th also comes to the top, and it becomes positive. Okay, let's try C. Let's see, I might be able to make this bigger. Okay, there's a lot going on here. One thing, you need to distribute this exponent first. So do not start canceling yet or subtracting yet. Distribute that exponent. So that makes it x to the negative 6th, and then y to the 6th when you multiply. And then on bottom, we won't do too much with the x and y's, but the z to the 0 power is just 1, and you don't have to write 1 there. I'll put it there so you can see where it came from. But z to the 0 is 1. And then let's do, there's different ways to do this. You could just subtract. A lot of times what I'll do is take the negative and go ahead and move them. A lot of times subtraction leads to error, negative signs lead to error. So let's just move that. So that's y to the 6th, and then x to the 5th, x to the 6th from the top, and then y to the 6th. So these guys here, this y to the 6, y to the 6, they will just essentially cancel or divide, or 6 minus 6 is 0. So there's nothing left on top, but there's a 1 there. You got to have the 1 for a placeholder. And then you can add those exponents to get x to the 11th. Okay, and then a reminder to try this one before we do it. There's negative stuff everywhere. Let's deal with the numbers first. So the numbers out here, the 16 and 2, those, it's just like a fraction. So 16 over 2 reduces to 8. So 8's on top. In the negative fourth, because I'm just going to move it to the bottom to make it positive. Into the negative fifth, let's move that to the bottom and make the exponent positive. And then into the negative third, let's move that to the top and make the exponent positive. And once again, you don't have to necessarily do that way with the ends. You could subtract, but if you can make things positive, normally there's fewer mistakes. Okay, and there's more than one way to do this. So the 8 and the m to the fourth, there's nothing else to do with those. And with subtraction, okay, so I'm going to start with the bigger number. So the bigger number is 5. So it's on bottom. I'm going to end where I started. So into the fifth and then into the third. So 5 minus 3 is 2. Because the bigger number was on bottom, my 2 goes on bottom. So always end where you begin with your subtraction. And if you start with the bigger number, that way you won't have negative exponents. A way to kind of see that expanded, the reason why it's on bottom is because this is n times n on top, and then there's 5 of them on bottom. So 3 of them would cancel, and you would be left just with 2 n's on bottom, or n squared. Okay, on this one, let's see, just to do something a little different, let's reduce everything inside first. So if I have 3 minus 2 is 1, I guess I start with my 2 doesn't change, or it doesn't move. And then I have a to the first on bottom. And then if I move b to the first down and then add it to 2, that's b to the third on bottom. So my top is now gone, and it's raised to the third power. And now I just need to raise everything to the third power. So 1 to the third is 1, 2 to the third is 8, and then 1 times 3 is 3, and 3 times 3 is 9. Okay, on the next one, so this negative exponent, you can do this a couple ways, which is true for a lot of these. Let's move everything to the bottom to get rid of that negative exponent out front. Okay, so we didn't do much there, but we got rid of one negative exponent, and now we can go ahead and distribute. If you want to think of it that way, it's 5 to the third, and then s, you multiply up high, multiply, you get negative 6, and then 4 times 3 is 12. Okay, and so now we have well, you know, a couple things we can do. 5 to the third. If you don't know what that is, that's okay. Just type it in your calculator. 5 times 5 times 5 is 125. S to the 6 moves to the negative 6, moves to the top, becomes positive, and then t to the 12th stays there. And you don't need that 1 there. I had it as a placeholder. Probably don't write that. Okay, and then F gets a little more complicated. So make sure you're pausing the video, trying these out. Here, when you multiply fractions, just multiply straight across is what it means. And so we can just write it as one fraction and not really do too much yet. So 6x to the 5th, y to the negative 4th. And if you wanted to move the y up there, that'd probably be a good step. but I'll go ahead and show one more step. So the numbers don't get confused. Very, very easy to get confused and look at these numbers and like want to subtract them because we're dividing. But it is just your normal reducing of a fraction. So 2 goes into 6 3 times, so 3 is on bottom. 5 minus 3 is 2, and the bigger number was on bottom, so that's where the x squared goes. And then let's do this in 2 steps. Let's move the y to the 4th up and make it positive. You could also subtract. You could say the bigger number is 4. 4 minus negative 4 is 8. But that's a place of error and confusion. So we just try to get rid of negative exponents. And there's your final answer for that one. Okay, with scientific notation. One thing with scientific notation is try to break the habit, if you have this habit, of thinking like move the decimal left or right. So instead, kind of the rules, there's 1 digit to the left of the decimal. And then if it's a really small number, then your exponent is going to be negative. And if it's a really big number, then your exponent's positive. And the reason why I say to do it this way and not like thinking left or right, because left or right is kind of relative to where you are. And so that's very confusing to kids and just to people in general. Where if you think, well, if it's a small number, like 0.00005, that's like a small number. Then when you write this in scientific notation, you know your exponent's supposed to be negative. Doesn't matter which way you use the decimal, move the decimal, the exponent's going to be negative. And likewise, if you see, well, oh, I have a negative exponent, I know that's a really small number. And same thing with this. If I have the number like 5000, let's make it 5 million, I would know my exponent's supposed to be positive on this scientific notation. When you evaluate them, the same exponent rules apply. There's no difference in them, but it is a little confusing with this and the way it's written in the numbers. So like here to multiply, just multiply these two numbers. So I have 4.2 times 3.5. And that gives us 14.7. And then it's times 10 to the, and then you 10 to the third times 10 to the sixth is 10 to the ninth. So just add the exponent. Now this is not scientific notation. We need this number to be a little bigger. So I need to move this over here, 1.47 times 10 to the, and now because I moved it one more spot over, it's going to be 10 to the 10th. Okay, on the next one, I almost got to the bottom of my screen there. We're going to divide 8.1 by 9.4 first. And so that gives me 0.86 is what we'll round to. We'll keep one more decimal, 862. And then it's times 10 to the, and 7 minus 12 is negative 5. Okay, so this one's confusing to think about, like how to write it in scientific notation. It might be helpful to actually write this out. So if you were going to write this out in expanded form, you would take your decimal and move it 5 places to the left, or it's a small number because it's negative. So it'd be 0.0, 1, 2, 3, 4, 1, 2, 3, 4, 5, one more 0, and then 8, 6, 2. And so we can kind of count that out from where we were. 1, 2, 3, 4, 5. To make sure we're in the right spot. Okay, so that's what this number is. Well, I want to move the decimal point one more that way to make it 8.62. And now I have a small number, so it's going to be negative, and I can count the spots 1, 2, 3, 4, 5, 6 times 10 to the sixth. Okay, and we'll stop there with this video. Make sure if you have questions, please ask, reach out, figure out how to do these problems, and good luck.